A quick one on this. There was a question about this projects. Yeah, we're talking to some professors in different universities about doing a project together. So we got our CEO to write a description of a few projects. And there was a question if they're still available. Yes, they are available as they are open as long as I don't have to do anything. In other words, they are open for anyone to do these topics independently. I would normally start with a blog. So you can just take this prompt, go ChatGPT, take whatever the most powerful model that you have available for you, and start writing. Which one is better? Oh, we also have the deep research. They give you 10 deep research prompts per month. Can do a deep research on that, so we can essentially get let's do a quick summary. This is just primarily.
The project aims to develop a cloud-based interactive platform leveraging AI, machine learning, fuzzy logic, and XAI tools to simulate and analyze neurological disorders. By integrating deep learning, GAN, and synthetic data, the platform will enhance understanding and research in neurology. A web-based interface will facilitate global collaboration with an interdisciplinary approach engaging students from diverse fields. The outcome will be a user-friendly tool for educational and research purposes. The project invites participation from students interested in biomedical data and cutting-edge technology.
What's your opinion on the text, or how promising do you think this research project would be? Okay, more specifically, just taking the technical details out of this research project proposal, can you write instructions for a research scientist to use the internet, the web, and write a very detailed research paper on this topic? Yeah, we'll be doing deep research on that.
Below is a structured step-by-step guide on how a research scientist might use online resources to craft a comprehensive research paper on a virtual lab for neurological disorders project.
Yeah, that sounds promising.
Define your research objectives. Establish the primary question. Clearly articulate the main goal of the paper, e.g., how can a cloud-based platform leveraging AI, fuzzy logic, and XAI tools enhance the understanding and simulation of neurological disorders?
Should we do like a vibe? If you have vibe coding, can you do vibe research?
Explain the technical infrastructure, user interface components, and data flow. Results and evaluation. Present findings on model performance, user testing feedback, or collaboration metrics. Discussion. Interpret the results, discussing implications for medical education, research, and future directions. Conclusion. Recap main contributions, potential limitations, and next steps. References. Cite all sources rigorously using a recognized style APA, IEEE, etc. Highlight the growing importance of AI in healthcare, specifically for neurological disorders. Reference any existing virtual lab examples explaining the novelty of your cloud-based, AI-driven approach. Group references by themes, e.g., AI in neurology, fuzzy logic in biomedical research, XAI for healthcare. Critically evaluate methods. Discuss advantages and shortcomings of each approach, especially in data-limited or high-uncertainty scenarios. Show how your approach combining deep learning, fuzzy logic, and XAI fills existing gaps. Describe how you incorporate GANs, e.g., DC GAN, cycle GAN, and how fuzzy logic rules are encoded. Clearly define how LIME/SHAP or other is integrated to generate interpretable insights for medical professionals.
Let's edit it in Canvas.
Establish the primary question. How can a cloud-based platform leveraging AI, fuzzy logic, and XAI tools enhance the understanding, simulation, and management of neurological disorders? Examples. Which open-source datasets offer the best coverage of neurological disorders? How can fuzzy logic improve uncertainty handling in patient data? What metrics are most appropriate to evaluate the success of AI-driven neurological models?
Okay, we need to rewrite it as instructions for a researcher. It's writing it in a more open-ended fashion.
The instructions have been updated to assume the researcher completes all tasks in one continuous workflow, removing timeframes and online tips. How can a cloud-based platform leveraging AI, fuzzy logic, and XAI tools enhance the understanding, simulation, and management of neurological disorders? Clarify the intended impact. Is the aim to improve diagnostic accuracy, accelerate research workflows, or enhance educational tools? Identify secondary questions. Explore key aspects such as methods, relevant datasets, and essential technologies. Example questions. Which open-source datasets offer the best coverage of neurological disorders? How can fuzzy logic improve uncertainty handling in patient data? What metrics are most appropriate to evaluate the success of AI-driven neurological models? Define desired outcomes. Determine if the goal is to publish novel findings, develop a proof-of-concept system, or inform the design of a future clinical tool. Align research outcomes with real-world applications in neurology and AI-driven healthcare. Scope and constraints. Identify potential challenges such as data availability, computing resource limitations, or ethical consideration. Analyze seminal papers discussing AI applications in neurology, virtual lab frameworks, fuzzy logic, and XAI in healthcare. Below is a structured, step-by-step guide on how a research scientist might craft a comprehensive research paper on a virtual lab for a neurological disorders project. These instructions assume that the researcher completes all tasks in one continuous workflow. Results and discussion. Quantitative analysis. Report on AI model accuracy, precision, recall, and other metrics. Qualitative analysis. Summarize user feedback and interpretability evaluations. Comparisons with existing methods. Benchmark the virtual lab against traditional approaches. 11. Conclusion and future work. Summarize contributions. Highlight key takeaways from integrating AI, fuzzy logic, and XAI. Address limitations. Discuss potential constraints in data quality, model biases, or computational resources. Prepare all necessary submission documents, cover letter, ethical approvals, supplementary materials. Submit the research paper to the selected journal or conference and track the submission status.
We actually submit this paper. No, we would not be doing that. It will be published on a website. By the way, if you haven't checked the website yet, now it's a good time to do so because you can actually provide feedback.
Introduction. Context. Provide background on neurological disorders, their complexity, and why advanced AI methods such as fuzzy logic, deep learning, and explainable AI are valuable in this domain. Rationale for a virtual lab. Emphasize how a cloud-based, interactive environment can centralize data sources, allow real-time collaboration, and promote interdisciplinary research. Primary goal. Clearly state the main purpose, e.g. to create and evaluate a cloud-based, AI-driven virtual lab for simulating and analyzing neurological disorders. Develop AI models including deep learning, GAN, and fuzzy logic that handle uncertainty in neurological data. Integrate explainable AI XAI methods to ensure model outputs are interpretable by researchers and clinicians. Provide a collaborative platform for knowledge sharing and educational support. Scope. Specify the extent of the lab's functionalities, for example types of neurological conditions supported, data modalities, user-friendly dashboard. 3. Literature review. Search strategy. Identify and summarize key studies, open source data repositories, and existing virtual labs or AI tools in healthcare. Thematic organization. AI in neurology. Highlight machine learning solutions for diagnosing and treating neurological conditions. Fuzzy logic in medicine. Discuss the utility of fuzzy rule sets in handling ambiguity in clinical contexts. Explainable AI for healthcare. Outline the need for transparency in medical AI solutions. Existing virtual labs. Compare relevant platforms to demonstrate how your approach is novel. Filler. Methodology. Data sources and validation. Detail the open source or public medical datasets used. Explain data cleaning and preprocessing steps handling missing values, normalization. Include any validation processes to ensure accurate, reliable inputs. AI model design. Deep learning. Describe architectures, e.g. CNN, RNNs, and training procedures. Fuzzy logic integration. Show how fuzzy rule sets model uncertainty in diagnostic tasks. Generative adversarial network scans. Explain how synthetic data can address small or imbalanced datasets. Explainability XAI techniques. Describe which methods, e.g. LIME, SHAP, are integrated and how their outputs help interpret model decisions. Highlight how explanations can direct clinical attention to key features or disease patterns. Evaluation metrics. Present metrics relevant to clinical validation accuracy, sensitivity, specificity. Address reliability measures for fuzzy inference output and user trust in XAI. Hot. Implementation virtual lab infrastructure. Technical stack. Specify the frameworks Python, TensorFlow, PyTorch, and web technologies Django, Flask, and Boy. Cloud deployment. Describe how the system is hosted, e.g. AWS, GCP, Azure, and the resources allocated GPU, HPC. Collaboration and real-time interaction. Mention features that allow multiple users to simultaneously analyze and visualize data. Include details on version control, security, and access management. User testing and practical validation. Outline how usability tests are conducted to ensure researchers can effectively operate the virtual lab. Gather feedback on interface design, data input processes, and clarity of XAI results. Results and discussion. Quantitative findings. Present model performance metrics, e.g. F1 score, confusion matrices. Compare fuzzy logic enhanced AI with standard machine learning baselines. Qualitative insights. Report user feedback on platform usability, collaboration features, and clarity of model explanations. Discuss practical benefits, such as improved diagnostic workflows or educational value. Comparison with existing tools. Identify unique improvements offered by this platform compared to other virtual labs or AI-based systems. Emphasize capabilities that handle uncertainty or provide enhanced explainability. Ethical considerations. Bias and fairness in AI. Identify possible bias in training data or model algorithms. Suggest strategies to mitigate these biases and ensure fairness. Privacy and data protection. Address protocols for anonymizing patient data, if applicable. Mention any compliance with healthcare regulations, HIPAA, GDPR. Responsible deployment. Stress the need for clinical oversight in AI-based medical tools. Propose guidelines for auditing the system's real-world performance. Limitations and biases. Data limitations. Acknowledge if certain patient populations or disorders are underrepresented. Model limitations. Note constraints in interpretability, dependence on large training sets or potential overfitting. Scalability. Discuss technical hurdles when expanding to additional conditions or user bases. 9. Future directions. Platform expansion suggests integrating more neurological conditions, larger datasets, or advanced AI modules. Enhanced user engagement, propose training modules for students or a user community forum. Cross-disciplinary collaborations encourage partnerships with neuroscientists, clinicians, data scientists, and ethicists to refine and validate the platform. Are you looking for a fully developed research paper based on these instructions, or do you need a structured draft that you can further refine? Also, do you have any specific neurological disorders or case studies you would like to focus on within the virtual lab context? I will develop a fully detailed research paper based on the provided instructions. The paper will focus on the implementation of a cloud-based AI-driven virtual lab for neurological disorders, incorporating epilepsy and sensorineural hearing loss as case studies. It will include AI methodologies such as deep learning, fuzzy logic, and explainable AI while discussing technical, ethical, and practical considerations. I will ensure that all sections are thoroughly covered with citations and structured format.